Hello, sir. I'm Lokesh Fasreddy from Group G478, and our project is Medibot. Uh, our goal is to create a software for a rover so that it can be used for delivering medicines in an hospital. The robot can navigate on its own using computer vision. So, with the help of SLAM, we can achieve we are achieving it. So, for patient identification, we are using face recognition or QR codes, and with the sensor fusion we can have real-time decision making. And then I'm going to talk about system architecture. So whenever we capture an image with the help of camera, we are sending it to this midas. Midas is basically a transformer model which is used to retrieve the depth estimation. As the project is all about computer vision, so for that only we are using this midas. But midas only gives us relative depth, not the actual depth. So that's the con for this. We use orb for feature detection and extraction. And another important thing is this cliche. Like this is basically increases the sharpness of the image. Like this is very useful for detecting the walls and floors in the environment. And then finally, for patient identification, we use face recognition, as I said before only. In the SLAM core, we use the process visual audiometry. Like this process uses camera images to estimate the movement of the camera. So and then we use this landmark based mapping. In this, the rover identifies similar features, or we can like say it as landmarks, such as corners or objects, and use them to create a map. So for creating a map, we use this. And this landmarks act as a reference points to the robot so that it knows where the things are related to it. And then we have pose estimation and tracking. Here, pose refers to the position of the camera. So, by combining all these three, the rover continuously estimates its current pose and keeps track of it over time. So, and then we have a control layer in which we use the path planning algorithm we use is A star. As in the before milestone itself, I explained about A star algorithm. Once the rover knows where it is and what environment around it knows, so it needs to figure out the best path. So with the help of A star, it gives us the best path to the destination. And then and by avoiding a obstacle, we reach our destination. And then finally we give it to the desired patient. And then and then I'm going to talk about the technology stack. So all are pretty common here. Like we use Python for key libraries, matplot library, and a hardware river with camera. But one thing to talk about is our communication. We use HTTP streaming here. This is used for transmitting the live video feeds from the robot's camera to us. Like this allows us to view the robot's environment, which is very crucial for monitoring. And then we're going to talk about formulas here. Like in this formula, we have fx and fy. This basically represent the focal length of the camera along the x and y axis, and the cx and cy represent the central point of the camera, like the coordinates of central point of the camera. And then we have here u and y are basically the pixel coordinates in the image, and z is the depth value at that pixel. So by applying these equations, the image can be mapped to a point in a 3D space, allowing us to understand where the allowing the rover to understand where the position of the object is. So then we have voxel grid hashing, where like this gives us the a key or index that basically represents a specific cell in the grid. So like instead of tracking every point, we can just organize them into chunks, which makes it more efficient and the computations more faster. So it is basically whatever I said, all are there in this one slide in a order. So then we go to performance matrix. So like this is the range of the feature detection from the image we get. So at least to work with, we have at least 50 in a range of 50 to 150 range, at least the number of features that is detected, and the processing speed of it is at least 50 to 20 fps, and the map accuracy is around 80%, which is fine. And like this also I discussed before itself, like we use Clash A and we use HTTP streamer here, and we can just check it out in the PPT itself. Like a challenge and solution, the biggest issue was the poor feature, the poor feature detection. So that's why we use a Clash A, so that the walls and the floors can be detected easily. Here, we used ORB instead of fast, because the efficiency of this for feature detection is very less. Like it is not in the range of 50 to 150. So we used ORB for it. Like here, when there are too many pixels, the memory is just too the memory taken is will be too much. So to overcome that, we are grouping all of them so that the computation for this will be very less, like I said here before. So then uh, the key learnings we have is like we learn to implement this visual audiometry and landmark based mapping. Like we use SLAM for it, and we use sensor fusion for it. And one final thing I'm going to talk about is real world applications. Like during COVID, there shouldn't be any physical contact. So, like some in future any pandemic occurs, like this rover will be very useful. So there won't be any physical contact in delivering medicines. So that's one major application of this. And then finally, I'm going to show this rover. Um, as you can see, this rover is moving in a square shape. So this is moving in a square shape, and with that we found the path of this. Like in a map, it's showing that it has moved in the square shape. So that's it, sir. Thank you.